Hi, welcome to our second video on weather, and now things are going to get a little more exciting. Let's begin by talking about how clouds form. To form a cloud, you need to lift up air, and there's three ways to lift up air. There's convectional lifting, and that's where the warm air rises. And so as warm air rises, more air comes in, and you get convection currents happening. And the warmer air, as it reaches higher altitudes, it's going to experience a drop in air pressure, so that air will expand, and as it expands it cools off. And cooling off, you can get more condensation, meaning water vapor changes into liquid water or tiny little raindrops, and that's going to form the clouds. The second way to lift up air is through orographic lifting, and that's where the surface winds can push warm moisture up the side of a mountain or some other obstacle. And the third way to lift up air is through weather fronts. So let's see, the two main weather fronts are a cold front and a warm front, and it just depends on which mass of air is moving. So if you have cold air moving in and contacting some warm air, well, warm air rises, so the warm air is going to go above as the cold air moves underneath it. That's a cold front. A warm front is where the warm air is moving and approaches some cold air that's basically standing still, and then the warm air is going to rise. It's going to go over the top of the cold air. And in both cases, the warm, moist air is going to go up. It's going to be lifted. There's two other fronts we can be concerned with too, and that's a occluded front. That's where both the warm air and the cold air are moving, but they're moving in the same direction, and one moves faster. So one of the fronts overtakes the other one. So let's say maybe it's cold air that's moving faster, approaching some warm air that's moving, and the cold air overtakes it and goes underneath the warm air, lifts up the warm air. And then you can also have a stationary front, and that's where, after the warm air and the cold air kind of move together, they stop moving, and now they're just bumping into each other, and neither air mass is moving. So you may have seen some older weather maps where they show these cold fronts as these little spikes on a line. Warm fronts have these little round half balls. Occluded front, remember, that's where one front overtakes the other, and they're both moving in the same direction. So we both have the cold and the warm fronts moving the same direction, and the direction is given by the direction of these little points. So little flags, if you will, are kind of pointing in the direction of the motion. And then a stationary front, well, neither one's moving, so we're kind of showing the flags in opposite directions, indicating no motion. Okay, after you get the air lifted up, the warm, humid air up higher, then you can form some clouds. And there's basically two general types of clouds that can form. Remember when we talked about stable and unstable air? The stable air was air that if you lift it up, it wants to descend back to its original location. And if you have stable air that gets lifted up, that produces stratus clouds. And stratus clouds are like lifting a layer of air. So the clouds look more like a blanket, like this first one here. Unstable air, it's propelled by convection currents. And so we get these vertical looking clouds, like this one over, looks like the Grand Canyon. And those are your two general cloud types. If you get a stratus cloud appearing over the surface of the ground, that's called fog. And then you can have clouds that are a mixture of these two types, both stratus and cumulus. And so here's a little diagram of some general cloud types. The cirro and the cirrus have to do with ice crystals rather than liquid water droplets. And it looks like the nimbus are those clouds that are generating a lot of rain. Okay, here's a little bit more detail about our cold and warm fronts. So here we got the cold air that's in motion and approaches some warm air that's relatively still. The warm, moist air then gets lifted up as the cold air rides underneath it. And the motion's fairly sudden, so then you can get some thunderstorms. A warm front, however, is where the warm, moist air just comes in and rides over the cooler air that's staying still, and it's more of a gentle lifting. And so you get some rainstorms, but usually the weather isn't so severe. Let's take a look at some severe weather. Let's begin with thunderstorms. Okay, a thunderstorm begins by forming a very large cumulus cloud, and again that's through convectional lifting, where the warm air just rises up, and it's very moist, and so as it rises and encounters lower air pressure at higher altitudes, and this warm air then expands. As it expands, it cools off, and then that allows rain to form, little tiny raindrops. Now these droplets then are heavier and they start falling downward. But more moist, warm air continues to flow upward, and it kind of pushes these little tiny raindrops back up to the top of the cloud. Also, as these little droplets fall down, they hit this warm air and they evaporate again. And so we get this cycle of more moist, warm airs being drawn upward. It's going to expand and condense and form tiny little droplets, and those droplets will fall, but they'll be carried upward by the updrafts, and they'll also evaporate in this warmer air. And the cycle just keeps continuing until the cloud builds up in mass. There's a lot more water content in the cloud, and we reach the point where the warm moist air comes up, and as it expands, the new air coming in generates some tiny droplets of water, and then up above, these droplets of water are descending, and they'll collide with the new drops that are forming. And that's going to create a bigger raindrop. And now we're at the point where the raindrop is large enough, heavy enough, it can fall with enough gravitational force and fall through the updraft. The weight of the raindrop is too heavy for the updraft to keep lifting it. And so finally, these large raindrops will fall out of the cloud, and you'll get precipitation. You get rain. Oh, and it's kind of interesting. As these raindrops are lifted up and swirling around, some fall, some move up, they rub against each other. And just like scuffing your feet against a carpet generates static electricity, so too do these little droplets as they rub past each other, some going up, some going down, they generate static electricity. And it turns out the positive charge generally builds up at the top of the cloud, and the negative charges build up at the bottom of the cloud. And it's just a big charge separation here, a lot of static electricity, until finally it discharges and the electricity strikes the ground as lightning. Okay, how do tornadoes form? Well, it begins with those updrafts, the warm air rising, convectional lifting, and as the air rises up, it vacates the surface, and that creates a low pressure zone. And so air from the surrounding area rushes in to fill that low pressure. Remember, wind moves from high pressure to low pressure. And then as the wind approaches this low pressure zone, wind that is in contact with the ground is going to experience a lot more friction, and it'll move slower. The wind that's higher off of the ground is going to move faster. And then the air that's caught in between is then going to start to spin, a swirl of wind. The spinning air will then contact the forming thunderstorm and be pushed up by the updraft. So you get the spinning air moving up into the cloud. And that's going to keep happening as more warm air rises. You keep getting the updrafts, and as air rushes in, it's going to continue the spin. And as long as this happens where the air is doing these big looping spins, you don't have any tornadoes. But consider an ice skater who's spinning, and she has her arms extended way out. With her arms extended way out, she's going to spin slowly. But as soon as she tucks in her arms, she's going to speed up. Well, that's what happens to create a tornado. Sometimes these big looping spins of air will tighten up. The radius of rotation will shrink up, and suddenly they'll spin much, much faster, just like that ice skater. And that'll create a tornado. So here's some pictures of tornadoes. She makes me nervous. Hurricanes form over the ocean when several thunderstorms merge and combine into one storm. And so each thunderstorm had its own updraft. Well, they merge into one central location where you get a low, very low pressure area. And that's going to continuously draw in more moist, humid air from the surface. And then as that humid air rises up from the surface through the updraft, it's going to spin because of the Coriolis effect. Remember, the rotation of the Earth causes the air to rotate. It's counterclockwise in the northern hemisphere, and it'll be clockwise in the southern hemisphere. So the updraft starts to spin. Yes, and so all the hurricanes in the northern hemisphere are going to spin counterclockwise. Hurricanes can build up in strength as they continue to form more raindrops. So there's energy in that. Think about boiling some water. If you want to change liquid water into steam, you have to add heat. You have to boil it. Well, where does this heat energy go? Well, it goes into separating the water molecules into gas molecules, into individual unstuck molecules. Well, when you form rain, you have to do the reverse. You have to condense or bring these water molecules together so they stick together and move more slowly and stay bound together as liquid water. Well, the extra energy then has to come out, and in a cloud, the heat energy that comes out goes to warming the surrounding air. Well, what does that do? Well, as this updraft brings up moist air, the rain forms and heat is released at the upper areas of the forming hurricane. And as it warms the surrounding air, it's going to rise faster. Remember, warm air rises. And so as you further heat up the air, it's going to rise up faster, and it's just going to begin to suck air right off of the surface, and that's going to add power and speed to the hurricane. So the hurricane's going to keep doing this and build up more and more energy as long as it's over the ocean, where it has a source of this warm, moist air. If the hurricane approaches land and goes over land, well, then there's not a lot of warm, moist air over land, and it'll lose its energy, and the hurricane will dissipate. You can also have high winds at high altitudes, blowing and disrupting the swirling wind. That can also disrupt a hurricane. Okay, that's all for now. I'll see you in class.